Shall we start? Maybe 1 more minute, 2 more minutes.
In a module exam, question will be there.
Sorry?
In a module exam, question will be there.
Reading the model end-to-end case study mostly.
Like data set will keep all this.
You have to begin with the data cleaning, building the model, all of those things. You're already thinking about the exam, huh? Huh? Okay, so I think we spoke about this. Am I audible online?
Yes, sir.
About this, any questions on this before we go on? All good, huh? Okay, so why don't we begin with this? I will share maybe 1 or 2 notebooks with you. And I know this is not there in my blog, and I don't want to spend too much time typing these things. So you can run it on your end, and we can have people come in and explain from your point of view. So I'll share that on email with you, Abhi, and you can share with everybody else, right? So this is the first one in the data cleaning, and we'll be looking at more. You can share with others, Abhi, and then once you run it, we can begin the interpretation on it. That will be better in my view. You don't have it? No, I have sent to Abhi by email.
Some point of time. No, it says. Sorry, so that notepad book is working here. That's the one which I was showing you. In Google Collaboration.
That's good.
Let's say. There is a character following.
Shall we start? You have the code running? Some errors, okay. On purpose, I have kept some of the things up and down, so you guys need to figure it out, what needs to be fixed. Some challenges? But there's some other problems in the code. There are some errors. Should you fix that? Yeah. That's what I mean. On purpose, I figured you something which is not working. Fix it. Otherwise, what is the point? You just simply run the notebook. Some order of the code also you change, move up and down. See what needs to be done first, then second.
CS.
How many of you have got the entire code working? Raise your hand. No one. Still working on it? Okay. I already gave you the hint. Just move certain code up and down. You'll be able to figure it out. Look into the errors and move some codes up and down, and that should be it.
So there are code related to decision tree. Is it required?
Not required. Only the data cleaning portion. Decision tree is not required.
The train test.
That you will require. Train test split and all those things.
Is required.
That is required, but not building the decision tree as of now. Okay, shall we start? Even if you haven't figured out, you can while we go through. Is that okay? Or you want more time? You want to experiment a bit more? Let's go one by one. I think that will help you clarify. So I think this is quite straightforward. Anything which looks new to you? We have done Seaborn earlier, right? And matplotlib also earlier in all of that. We have done that, right? So NumPy, Pandas, PyPlot, all those are usual things. So let's continue down. So this is running fine, right? What is this line doing?
So your screen is not shared. Sorry to interrupt.
Screen. Okay. Just a second. Now,
Yep. Okay. Thanks.
this line is the magic command, which will help you print multiple things on the same line. Yeah. So far, everybody is with me. Then we are importing the data, Titanic data. Where is this data coming from? Seaborn library. Yeah. So this is coming in from the SNS, which is a Seaborn library. We are doing the head and the tail. What is head and what is tail? Top 5 and bottom 5. Yeah. Okay. Sounds good. Let's carry on then. And then I'm doing some timer thing. You don't have to worry about that. So then what we are doing over here is dropping certain columns, right? Why are we dropping these columns? They're redundant columns, right? Because alive is similar to survived. Class is similar to passenger class, similar meaning exactly the same information. Who might be like the male, female, embark town is SC, and so on and so forth. And deck we are dropping because there's too many missing values there. So let's go ahead and run that. Okay, because I have already dropped, I mean, I have to rerun this then, I believe. Let me do this so that if I am breaking certain flow, then I will get to know, right? So I'm just restarting the session and gonna run one by one. So this is fine. We have already discussed that. This is fine. We will run this. I will not run that, and then I will run this. We were here, right? So okay, so it has run. This is clear, right? In place, true, axis 1, all of those things are good, right? Okay, cool. Then we are doing the Titanic head, and you get to see this. So I'll wait for all of you to confirm you have this data frame view. Everybody has it? Okay. Then we are doing info. What do you make out from the info?
Columns, how many of them are null and what is the data type of the column?
That's right. That's right. Yeah. So how many total data we have? Rows 891. And we are missing some values in age. 714 are non-missing. But then there is also missing values in one more column. Can anyone tell which column? Embarked has two missing values, right? So one of the things that you'll get to know when we look into the entire pipeline, for any data cleaning, you have to fix these things, which is the missing values. You will have to do the dummy coding. Have you guys done any dummy coding exercise earlier? No, okay. Then we have to do the outliers treatment. So missing dummy outliers. I think those are the main ones, right? But you have other feature engineerings. We'll see what else is there in the notebook. So right now we're going to work on the missing values. Then we'll be looking into the dummy coding. Then we'll be looking into the outliers, and then we'll fixing them so that our data is ready for further ML activity, right? So with that as the background, let's go on. And any ideas what this is going to give us?
How many
Yes.
null values are there?
So is NA going to check for the missing values? And then it's going to do a summation of that. So how many missing values we have in each column? So you can see that age has 177 missing values and embarked has 2 missing values. Now tell me whether these need to be fixed or no. Why? Because there cannot be a person who doesn't have an age, right? Every person has an age. As long as you're living, you have an age. So there cannot be a case where somebody is there on that ship who doesn't have an age. So age must be there. So that's what we're trying to fix. And similarly, embarked, they just did not come on the ship directly, right? So they would have boarded the ship from somewhere. So that's why we need to fix that also, right? Dropping is the last thing we should think about doing. Yeah, so try to fix impute basically. So try to impute with mean, median, mode, other values that you're happy about. And that way you can still use all the data that is there, right? If very, like, I mean, if you don't have any idea of, how to fix that, then there are some cases where you can drop them. If that data is redundant, right? So if we do the shape, it's coming out and saying that 891 and 8. So 891 observations and 8 columns. Now there might be certain duplicates, rows, which are duplicate, right? Exactly the same data is there. So if we do df dot drop duplicates, which is drop duplicates is a method within the df module, you will be able to remove any duplicate rows. So let's see what happens if I run this. So you can see now I have suddenly become 780 rows and 8 columns. So there were quite a few duplicate rows per this data. And your data could be different, like depending on where you have got the data from. But from the Seaborn, you should get exactly the same result, which is 780 rows and 8 columns. Is everyone with me? 780? Huh? You don't have, then you can type it in. So Titanic is equal to Titanic dot drop duplicates. And then we're going to do a shape again. So the first thing is, if there are duplicate rows, there's no point for us to have those duplicate rows in the model. You should remove the duplicate rows. It is checking on the basis of all this information that is there. Like, if all the things are similar for a particular customer, for example, if there was a survived customer and they happen to be third class passenger, female, same age, they paid the same fare, they boarded from the same city, then there's no need. So it is. That's right. That's right. In this case, I mean, probably you're better off not dropping the duplicates because they might be like, exactly because we are not looking at the name. If name was there, then we would know that these are not duplicate, right? So there could be a female, same age, same fare, same city.
Is it complete?
This is complete row, complete like across the different columns. If there are duplicates, it will be dropped. Then it will be kept here. Yeah. But up to you whether you want to do the drop duplicates or you want to move forward without that. Is that okay? Okay, moving on then. After I drop the duplicates, are we doing this or no? I think I have moved up. Yeah. Yeah, here. What do you think we are doing now? 773. Huh? Reran. So,
Yeah.
okay. So rerun all of the code and then you will fix it from big. So what do you think we are doing over here, folks?
We are
Hmm.
collecting all the rows where age is none.
Missing value is
Yeah.
missing value.
We are creating a brand new DF called Titanic Age Missing, right? And that DF is going to take the original DF, which is Titanic, and it says only give me those rows where age is missing, right? And then you're doing a head and shape of that. So you have 104 observations where the age is missing. And you can see the age is NaN for all this data. Clear? Shall I move on then? And then why are we doing this? ILOC 19, 26, 28. Okay, I think that's where this is going to be fixed. Is that what it is? Yeah, 19, 26, 28, where the age is missing. You can see these observations. So let's take a look at this line. Titanic.iloc. Everybody remembers the lock and iloc from the Python days, right? So iloc is the index based on iloc is a slicing based on the index, right? So we are saying, give me the rows 19, 26, 28, and give me all the columns, right? So remember the iloc syntax for a refresher is this df dot iloc, and then you're looking at the row reference, and then you're looking at the column reference. So in this case, the row reference is nothing but a list of these three rows, and column is nothing but all columns. Clear? So the reason why I'm doing this is so that you can see what happens when these missing values are fixed, right? NaN is fixed, then what happens really after that? Okay, so let's go on. And then here we are renaming. This is completely optional, but up to you whether you want to do it or not, right? So sex becomes gender, CIV becomes siblings and spouse, and so on and so forth. I don't like when there is something in uppercase, lowercase, this, that, and all of that. So remember the Pythonic name nomenclature, which is the camel case. So bringing everything to the lowercase and then using the camel casing so that it's easy for us to remember what is what. Is everyone with me so far? Okay. This have we done earlier on, categorical? Have we seen this code earlier? Anybody would like to take a stab in explaining this code?
It is going, first it is checking how many columns are there,
Mm-hmm.
and it is doing a loop, for loop from each column, and it is taking the data type of the column. If that is of type object, then it is converting that object type column to a categorical column, like codes will convert to that column is it will assign a numeric value for that particular column. For example, like if survived and embarked, we have three codes. So it will assign one code as a 1, another code as a 2, another code. It's 3, 1, 2, 3 kind of.
Yeah. So this is the activity of dummy coding. So, huh? Yes. Yeah, that's correct. Yeah. So this is the activity of dummy coding, and dummy coding is nothing but, hold on just a second. Okay, I don't know why the syntax is not coming in. Anyways, let's just remove the bold. So dummy coding is nothing but, you can make a comment for yourself, is converting categorical variables into numerical ones. And remember, this is a must-have requirement for any AI ML algorithms, that it does not like anything in the non-numerical format, because computer does not understand anything except zero, ones, and numbers, right? So if you have text, text needs to be converted to the numbers. If you have image needs to be converted to the numbers. If you have, categories like the SC and Q, which is the the city where they boarded from, that needs to be converted to numbers. Is that clear? None of the AI/ML algorithms will directly take the text. Even if they're taking something on the surface as a text, they are converting them internally into the numbers, right? So some of you might be working on like some Gen AI things and stuff like that. You know that we have something called as embeddings, which are representation of the text, right? Which is again conversion of that the non-text information to numericals or numbers, right? So this is one way of doing that. There are many, many different ways of doing that. So pandas, get dummies. You can do that. I mean, so I have some. So you don't have to necessarily zero. Anything in Python starts with zero most of the time, right? So what it is doing is instead of me going, so remember, I mean, I think before I run it, I wanted to show you this. So let's say Titanic.info, right? Let's run. I hope I haven't run the next one. So which one of them, these codes are non-numerical? True, gender and embark, right? So these are non-numerical. If I go and plug that in any ML model, it will say string, str, error, and stuff like that. So none of the ML models like the text or non-numerical information. So they must be converted. And there are many ways of doing that. So there is like, one hot encoding, there's pandas get dummies, right? There's many, many different ways. I follow, or I mean, I mean, you can follow also up to a large extent is this simple one, right? And what it is doing is following. So I think if loop, for loop, we have done in the basic Python class, we're leveraging doing that, right? So we are iterating over Titanic.columns, right? So what does the Titanic.column really have? If you don't understand, just type it in and you'll see Titanic.columns, right? And you will see there is basically it has all the column names survived and all of that, right? So what we are doing over here is we are saying for X in Titanic.columns. As long as you have something in the Titanic.column, so basically it's going to iterate over this iterable. Says, okay, let me iterate over this and let me go and then do the next thing. What is the next thing it's going to do? It says if that Titanic X meaning that column name comes in as a slicing. So it will say Titanic survived data type. Is this equal to object? This is an equality comparison. It is doing a Boolean comparison. It is saying, can you please check whether Titanic survived data type is object? And if that is the case, then go ahead and do this. However, if it is not object, you please exit the loop and come back to the beginning of the for loop. Is that clear? So it checks the survived and survived is numerical. So it exits the loop. Passenger class is numerical. So the very first object it encounters is the gender. Says, okay, fine. Yeah, I have found the first one, which is really object. So what should I do? So it says, okay, if you find an object, convert that into the categorical. Remember the categorical we spoke about earlier, which is, fixed number of categories. So this will not work for free flowing text, for example. So for example, if I'm, having paragraphs after paragraphs of information, this is not the right way of doing the conversion to the numerical data. It is only going to be helpful when you have fixed number of categories. And we know that because the gender is male or female, right? Similarly, the embarked is Southampton, Queenstown, and Cherbourg, 3 cities, right? So there is only fixed number of categories. So that's why we're saying, okay, yeah, go ahead and convert them into the categorical. And once you've converted them into the categorical, convert them into the quotes, which is NumPy pandas method, which is quotes meaning alphabetically it will say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like this, right? So in this case, here we had female and male. So what will male become? The very first row? It will become 1. Because female comes alphabetically, F is first, right? So F will become 0, male will become 1. Let's say if we have another gender type which says, yeah, others, for example, right? So what will others become? Will become 2, right? So that's how basically it is, right? So it's just going to go in alphabetical order. Whatever is the first one, that becomes 0. Whatever is the next one, that becomes 1. And then next one, 2, like this, it will continue going on. And that's how it's going to do the dummy coding for you, right? That's good. So which city is 2 now? Who can tell me? So we had Southampton, Cherbourg, and Queenstown.
Queens.
Queens, let's see. No, no, I think we have something else. So which all cities we had? Can anybody tell me the code to find out which are the different cities that we have before I run this code? So Titanic, and then let's do the, what do we look at? Embarked, then
Embark Town, then value counts.
Embarked Town, or no, Embarked only?
Embark,
Dot value counts.
Huh?
it will be giving.
Dot value counts you can.
Let's see, dot value counts.
Yes.
So you can see these are the values. So S, C, and Q. So C will become 0. Then comes,
Yes.
Q becomes the first one.
Yeah.
Right. So Q becomes the one, and S comes after Q.
Correct.
I think it's very confusing because everybody takes that Q will be the last one, right? But Q, R, S, T, U, V, W, X, Y, Z, right? So that's why the S became 2 and C became 0, and then so on and so forth, right? Is that clear? This step, this is going to be like, any machine learning algorithm you're working on, you will use some sort of dummy coding. This is only one way of doing the dummy coding, not the only way of doing the dummy coding, but good one. I mean, it works, right? And people who are not happy with this, I think you can do your own mapping. So I have a blog that you can refer to for doing this. I hope that is working just for the dummy coding point of view. So you don't have to type it in. I mean, that you can try out later on. Number 22. So for example, like you can see there, these are different ways. We can do pandas, get dummies, looping, mapping, and all of those things. So I'm going to show you one of them. For example, another way of doing that. So we can do the label encoder, one hot encoder, all of those things are there. You can try out later. Here I'm using the get dummies. Here you can do the mapping. So instead of it deciding by the numbers or the alphabet, you can say female will be 0, male will be yes, right? Or you want to flip it, you can flip it also, because if it confuses you that, I mean, this and that, so you can do male as 0, female as 1, right? But then you have to remember what is it that you're doing in terms of doing that. But I'm using this last one, which is, it's gonna alphabetically sort it, right? And there's a good Kaggle kernel that you can click on for learning more on doing, better data cleaning. So I'll leave it for you to try it out. But this will definitely, to your question, Arpan, this will definitely be something you'll be tested in your exam, the data cleaning and the pre-processing, right? So better the data cleaning, better the pre-processing, better off you are personally. So let's carry on. So till now, everybody's good with me? Now, what do you think we are doing over here? We are not filling yet. We're just finding out. We're just finding out what is the median for age. Median is 28. Now, who can tell me after the statistics class, how do I interpret this 28?
Or 50% of the passenger are of 20 age 28 or below.
Below. Is that clear? So half the passengers on the ship are 28 or less in age. Either 28 or less, or you can say the other half is more than 28. That's the median, correct? So what we are saying over here is, since we know that there are a lot of missing values, and how did we fix the embarked? I mean, it shouldn't be fixed. Okay, no, I haven't run that, so that's why. Never mind. So over here now you can see, if you remember those rows, which rows had the missing values? 19, 26, and 28. The age was missing, right? And after we fix them, we'll come back and take a look at them. So what we're going to do over here is a very simple plain vanilla technique that we are saying for Titanic age, fill NA, fill the null values with the median of Titanic. Now, if you're not happy with median and you want to fill with 50, for example, you can specify 50, but then you must have a good business rationale why you are filling with 50. You cannot just pull a number out of thin air and say, I want to use this one, right? So there should be some good rationale. What is going to be your imputation strategy? So either use mean or median or mode or some other number that you're comfortable, right? So why do you think so? It depends on your data skew, right? So if your data looks normal, you guys understand the normal distribution now?
Yeah.
So then the mean and the mode and the median are the same. It doesn't matter. If your data has a right skew, like the tail is here, which number is going to be higher, median or mode? Or I mean, median and mean, which will be a higher number? Mean will be higher. How many of you agree with the mean is higher? Raise your hand. Mean. Median will be higher.
Median, mean will be.
Mean will be higher. So I will draw two lines. You tell me which line is which. I think, I mean, people are getting confused. So I'm just making hypothetically, right? So don't even go literally. And sorry, I was supposed to use a different color on this one. Which one is the mean?
Middle one.
This is mean. Or this is mean.
Blue, right side is the point.
So blue is mean. And the green is median. Or I'm also hearing from people that this is mean and this is median. So this is your top choice. This is your bottom choice. How many for the bottom choice? Pawan? Anybody else? Why do you think, Pawan, that is the case? Median will be higher. No, but median is not average. Mean is average. So then you're also saying the top one is the correct one, right?
So
Huh? What?
here, sir, if we are having simple word, if we are having lot of outliers, we should go for median because mean will be biased with the outliers. That's the statistics.
No, that's fine. But I mean, to answer Anupam's question, why not median? Why not mean? Why median?
Yeah, because if some in our case there will be I have seen this data. So there are few who are very young, very young. So and there are a few people who are very old. So if we give mean, maybe because of these outliers, mean can be biased. So
For the null data, you don't know whether it is an outlier or not.
no, if we can draw the histogram, we can see there is what is the frequency of the data.
But right now, before histogram, that is where the cleaning data is not for.
So the correct answer for the right skew is median and mean. What should be the symbol then in between? I'm still not giving you the answer. Median should be less than or equal to mean for the right skew. Right? Because mean average number gets affected from the outliers, as Arpan was articulating earlier on. Median does not get affected from the outlier. Right? So the best thing to remember in your mind is when the placement cells report their number, they will always emphasize on average salary. Average salary is this. You have to ask them, boss, tell me the median salary. And then they will tell. Right? Why average salary? One guy out there would have got $200,000 in UK or somewhere, some random place, right? They will first of all convert that salary into INR. right? Which is not fair. You have to like, incorporate for the cost of living differences. They will simply convert that into the INR. Then they will say, okay, average salary is this. So everybody's thinking, oh, average, everybody's getting like on average 15 lakhs. But when you look into the median will be like 7 lakhs. So that means 50% of the people are getting less than or equal to 7 lakhs, right? So that's what you have to be really aware of. And mean is a game for losers, in my view. If you are educated, you should always insist on median, right? So that's why my preference is for median, because mean can hide a lot of information. On average, everybody is sharp here, but there might be 5 people who don't have any clue of what you're talking about, right? So that's why on average does not work out, right? Half of your body is in refrigerator and other half is in the oven. On average, you're at the room temperature. So, but you're not comfortable at all, right? So that's what it is, right? So always insist on the median, at least to get the full picture. What exactly? So that's why I'm using the median. Yeah. So let's go ahead and fix this. So I'm saying replace the age with the median, and something went wrong. What went wrong? Okay, so it has the null values is not done, I believe. I haven't run the code. Yeah. Now let's try. Now it should work, right? So now you can see the age is suddenly all non-missing, right? We have completely fixed the missing values in the age, right? Now let's go and visualize these same observations that we were looking at earlier. And now you'll see suddenly all of them are 28, 28, 28, 28, because 28 is nothing but the median of the age that we have, right? Is that clear? We just fixed the missing value with the median. Okay, let's carry on then. So embarked, did we fix embarked already? Embarked, we fixed already. Where did we fix the embarked? No, somehow it is fixed, but how? Did I? Huh? No, hold on just a second. Let me just let me restart the session one more time. I think I didn't do the restart earlier on because I want to go step by step. So restart the session and clear all output so that I'm not confused, right? So this part is done. Allow me a moment until I catch up with you guys. This. Let me know if I'm doing the embark fixing anywhere, if you notice that, but I don't think we have done so far. Till now, we haven't done. Duplicate dropping is NA. That's all good, right? This is where we were. Renaming, right? Info, still missing. Columns, value counts, all good, right? So then dummy coding. Then finding of the median, replacement with the median. And damn, it's fixed. How? Huh? Sorry? No. That has nothing to do with that fixing. So what I'm thinking is,
Maybe on blank is also space.
Sir, once around that values.
okay. I think so. That's what is happening there. So when we're doing the dummy coding, let me run it after this just to see what is really happening. So I think dummy coding is doing something funny. So let me just do it one more time. Restart all. And you know what? The same code, if I run 6 months from here on, the output might be different. Because some of these packages go for the upgrade on their own, right? So the way the dummy, like the loop is working will be different now versus the next time. So don't be surprised. So I think that's what is happening. That dummy coding is doing something funny. Let me just confirm one more time. So where exactly that thing is being fixed? If that is being fixed there, then we'll fix before that. Otherwise, we'll just tell you how to do it on your own.
To remove it is working. Means 778 ember.
Yeah. So let's do this then. So till now, I think we haven't fixed anything. We have the info. and we have 889 missing, 714 missing, right? So what I'm going to do is before doing this, we will run this step, right? So let's take this guy up so that we don't go through the dummy coding loop first. And we are doing mode. Okay, so mode is done. And then this we will also take up, but before we run it, we will do something else. So mode, and then let's do one more time, which is Titanic.info, just to confirm there's a missing value for fixing this one, right? Yeah. Now still we have the missing value, so I'm not doing the dummy coding first. I'm fixing this missing value first, right? And then we're gonna run this one, and then we will do Titanic.info one more time. So slight change in the order, right? Titanic.info one more time. Okay, so let's go and run this one. So Titanic embark.mode. So you can see embarked is an object, categorical variable, right? So mode will be what for a categorical variable?
Frequency highest frequency.
Right. So where most of the passengers have boarded the ship from, right? So that means Southampton. Most of the passengers boarded the ship from Southampton. Just to confirm that, I think we did that activity earlier. So which is Titanic dot embarked dot value counts, right? So it will tell you Southampton is 644 times. Cherbourg is 168 times. And Queensland is 77 times, or whatever Q stands for, right? So that means most of the passengers boarded the ship from Southampton. That's where the ship started, actually. When the ship started sailing, it started from Southampton, right? So what we are saying is, okay, give me the mode of the embarked. And it says you have 0S. What does the 0S mean?
0 means highest frequency means index value. Index means that code of that particular port.
Right. So there is only one mode in this data. There could be a distribution where you have bi-mode or bimodal distribution, or there could be like distributions where you have three modes or trimodal or multimodal distribution, right? So for example, iris flowers, do you guys remember iris flowers? How many varieties of flowers do we have there? Iris, three. How many times they are there? Each flower, how many times?
50-50.
50-50. So there is a setosa. I'm not writing. Achha, I have to write here. Setosa, Varsicolor, and Virginica. Just refreshing your memory. They're all 50, 50, 50 times. So how many modes do we have in this distribution?
3 mode.
It's a trimodal distribution, right? Multimodal distribution, right? What does it mean? Like, if I count, there'll be one mode for Setosa, Varsicolor, Virginica, right? So which one should we consider then? What is going to be the true mode? So that's why it says, okay, you have three modes. So in this case, it will say 0, 1, 2. So what will be the 0? It will be a Setosa with 50 frequency. Then Varsicolor, I think VA with 50 frequency, and then Virginica with 50 frequency, right? So instead of looking at this, you would be looking at a distribution like this, right? And then it's totally up to you whether you want to replace with Virginica or you want to replace with Varsicolor or Setosa, but there's no missing value in this. But that's what this is really translating into. I hope this is clear. So it's all telling you that I have only one mode for you, and that mode is S. So there is no like ambiguity on whether I have multiple modes. So let's carry on then. You have to tell. So right over here. So that's what we are doing. So we are saying Titanic embarked, fix the missing value, and fill it with the mode which is sitting at the 0th location, right? And before we do that, I think we have noted down the location where it is missing. So this, assuming there is no change in the data from the time we ran last time. So before I do that, let's insert a code block here and let's run this, right? See, the number has changed a little bit because of that duplicate removal. But let's say only the, let's just do, that's okay. I mean, we can just continue with this, right? So you can see there is a missing value at line number 61. There is no embark down, right? So after we fix this, then it should be S. So let's go ahead and run that. So I'm gonna go run this line over here, and this line is doing exactly what we've spoken about. So it says fix the embarked by doing fill NA, and instead of doing the median, because the median is not defined for non-numerical data. Median is not defined, average is non-defined for the non-numerical data. So you have no option but to use mode, right? Or any other value that you want to use. So mode is what we are using. And if I do the titanic.info, now you can see this guy is completely fixed up. All good? So then I'm moving on with the regular flow. I think I wanted to just demonstrate this. So
Now we can
now you can do the dummy coding and everything. So I think dummy coding was acting,
finish.
it was acting a bit funny. So I'm just gonna come to that point. Now we are doing the, so you can see there's no missing value now. And we are good here. We are good here, right? And there's no missing value at all. Embark also is not missing. And all of these are becoming moot points. So I'm not gonna run through it. And then we are good to go, right? And deck, I have already removed, so I'm not gonna get to the deck. But for example, you don't have to replace the missing value with mode. You can replace with any string also. So you can say missing. If you do not want to dilute on the data quality, instead of replacing with something else, you can just say missing, right? And then missing will be codified as well down the road. Yeah? So all of that is good. Now we are coming to the point. So this is about the missing value. Any questions on the missing values? All good. Now we are coming to the point where we look into the outliers. And we're gonna fix the outliers. And you guys were talking about the Z-score and all of that. Who would like to explain what is a Z-score? Z-test or Z-score. Yeah. Who would like to refresh my memory? You were there in the statistics. X minus mu, tell me. So what does it mean? Standard deviation, right? So what does it capture, the Z-score?
It is standardization kind of.
Standardization, yeah. Oh yeah, that's another thing I forgot to mention. We'll do the standardization as well. Yeah, but tell me, what does the Z-score capture really? Z-score is nothing but X minus mu divided by sigma. X is the observation, mu is the mean, and sigma is nothing but the standard deviation, right? Z-score. And if your Z-score is high, that means you are like, I mean, let me just do the standard distribution one more time. I don't have enough space. Let's do this. This is your typical bell curve. Everybody is used to it now. This is your mean, mode, and median, because I'm talking about the normal distribution. They're all the same. They're all bang in the middle, right? And then we're looking at the first sigma minus sigma plus sigma, right? So this is 1 sigma plus, this is minus sigma, right? And then this is 2 sigma over here. And then there is different color. Then there is 3 sigma over here, right? So Z-score is nothing but how far away you are from the mean. It's a yardstick for measuring how far away you are from the average in that distribution, right? So why I'm saying that? Because Z is nothing but X minus mu divided by sigma. So X minus mu, let's say I'm looking at the X value over here. This is my X value. So X minus mu will tell me the distance like this, but I have to measure this distance in the metric of sigma. So that's why we're dividing by this. So higher the Z score, further you are towards the tail, right? And if the Z score is 0, what does it mean? You are the mean. You are the average. You're bang in the middle of the distribution, right? So because if mu X is nothing but mu minus mu is 0, and that means Z score is 0, right? In a standard distribution, the Z score will go as high as +3 and -3, and then that will incorporate 99% of the observations, right? How much is the population between the plus sigma and one negative sigma? 68% population will reside over here. How much over here? 95%, right? And this is 99% of the population, right? The problem with the Z-score methodology is that it doesn't work out for any distribution which is not normal, right? And how many of you are completely normal? None of us are completely normal, right? I mean, we're all having some sort of things, right? So same goes with the data. There's very little data which is going to be completely normal all the time. So that's why I don't prefer the Z-score based methodology for the outliers treatment, right? So what does the Z-score says? If you are over here in this tail, let's say if your Z-score is more than 3 or less than 3, I will treat you as an outlier. I will chop you and then I'll bring you down to the distribution, right? But what if my distribution is looking like this, right? Then I cannot use a Z-score based methodology because then I'm going to chop off my half the data. This data is gone, right? This data is not useful at all. So it's very, very aggressive approach for doing the outliers treatments. So, and similarly, there is a box plot based way of doing, anything which is more than this. Like, you have this, okay, yeah, let's do a refresher on the box plot as well. What is this line? This is median. This is?
Q2.
This is 75th percentile. This is 25th percentile. And this is minus 1.5 IQR, interquartile range, basically the difference between 75th and 25th. And then similarly, this is this, right? Even this is very aggressive because you're gonna like do a outlier treatment on a lot of data. So I also do not recommend this. And again, this is susceptible to the outliers, right? So the approach that I'm going to suggest is based on what we call as a flooring and capping, right? Flooring and capping meaning it should be the other way around actually. So cap comes first and floor, right? So flooring and capping meaning like, I'm going to define a floor for this data. I'm going to define a cap for this data. And any observation which is higher than the cap, I will bring them down to the cap value. Similarly, any observation which is lower than the floor, I will bring them to the floor, right? Now, typically, what is this floor? I can say floor is first percentile and cap is 99th percentile. So if I follow first percentile and 99th percentile, how much of my data is outlier? 2%. 2%, 1% on the higher side, 1% on the lower side. So I'm still following very good outlier treatment. Like, I'm saying 2% of my data is outlier. And if there is any observation, so for example, let's say the salary floor was 5 lakh rupees. I'm just giving you an example. Like in a particular company, lowest, the first percentile, that means 99% of the employees are earning more than 5 lakh, right? Similarly, the cap was, let's say, what number shall I say? 2 CR. 1 CR. Let's just say 95 lakhs. Right? So anybody, so let's say there is a CEO of the company, or really high guy, and he's earning like 5 CR. While 99% of the Janta is earning 95 lakhs or less, right? He's clearly an outlier, right? So what happens to his salary for the model building exercise? 5 crore will become 95 lakhs. We will not remove that observation. We'll keep it there. But instead of recording his salary as 5 CR, we'll say his salary is 95 lakhs because of this outlier treatment. For all the features, yeah. If you want to do that, I mean, but there's no mandate that you must do everything. But I mean, unless you have any reasons why you want to have the outliers, you should fix them. Because then you're modeling for the class, right? For the overall distribution. Or if you think CU is not necessarily a representative of what I'm trying to do, then remove it completely, right? Similarly, let's say there were 5. You can remove that row. So let's say you're just trying to build a model to capture the salary as a function of pedigree, years of experience, technology, like any number of fields that you're looking at, right? Location. And then you think this observation is not fitting in. You can either bring it down to the same, which is the ceiling or the capping over here. And then similarly, let's say there are 5 employees or let's say 15 employees. Their salary was between 1 lakh to 5 lakh rupees, right? There's no point for us to really struggle trying to model for, why these people are earning so low. So we'll say, okay, we're going to bring their salary back up to first percentile, which is make their salary as 5 lakh rupees, right? This is what it does in principle. How much outlier you want to fix, for example, right? Look at the distribution. And it's art and science. I was talking to somebody during the lunchtime that AI is nothing but art and science, right? So you will try fixing certain outliers, see what sort of results you're getting. Is it a good model or not? You will try with different type of outlier treatment strategy. Then again, see, whether you're getting a better model or not, right? And then that is how you're gonna zero in on what makes sense, right? So, but in this case, 2% of my data will be considered as an outlier. What if I consider 5th percentile and 95th percentile? How much my data is outlier? 10% of my data will be outlier then. This will work for skew. Z-score and interquartile will not work for the skew. That's okay. That's okay. That's okay. Yeah. Right. So let's say there was like this sort of skew, right? So 99th percentile was somewhere over here. All these, basically what you're doing is I'm chopping off the last 1% of my tail. So then it will become like this, for example, the distribution will become like this, right? So all these values, so you'll see slightly higher, peak will be slightly higher artificially because more observations are there. So all these observations which are spread in the first percentile are like packed over here, right? So, but you haven't changed drastically this distribution, right? The only thing that you're going to see is there is a spike which is going to come in over here, right? So that's all we are doing. If you do for the 5th percentile, maybe you're going to chop it over here. So then this tail will suddenly look like this, right? That instead of just tapering down and down, because now I'm packing more observations in the 5th percentile, it's going to suddenly peak there. So that's all basically does in terms of the flooring and capping. If you follow the Z-score, you can still do that, which is Z-score of ±3, right? Or you can say Z-score of more than 2.5 if you have one side outlier. Or if you can, if you have negative, you can say Z-score of -2.5 and all of that, right? So all of that is completely up to you. Or you do the IQR range, but I follow this one, which is much more robust, right? So let's look into this example. You can use, if the distribution is normal, then you can do it, yeah? 100%. So let's run this one. From here, I think we have fixed all the missing values. Everything is now numerical and describe. So you can see this is how the distribution is coming in. So which one looks like an outlier to you from this data? Which of these variables have some outliers? Age. Age minimum is 0.42, okay? And
lot of variation.
There is one variable which is a massive outlier.
Right.
Siblings, nope. It's right there, looking at you, saying, pick me, pick me. Huh? Fair is the correct one. Why do you think fair has the outlier?
Mean and median.
Right. So you can see the mean and median test also is there. So let's look into the mean 0.38 and what is the median 0 over here, right? So survived, which is fair. Why? Because 0 and 1 are there. So that is understood. It's going to be there. Median are not going to be exactly the same, right? But if you come to the fair, you can see 75th percentile was 31 pound and maximum is massive 512 pound. There's a huge tail, or I mean, like, outlier spike, which is on the higher fair side. But let's not trust our wisdom from this chart only. So we're going to do this, right? So let's do Titanic.quantiles. And instead of now looking at a plain vanilla describe, I'm doing our own custom quantile. So I'm saying, give me the 0th percentile, give me the first percentile, give me the, I think we should also have one more, which is 0.05 percentile. And then we're going to do 95, 99, and 100th percentile. Shall we do it? Now, anybody who can tell me? Is that choice more obvious? Why fair has outliers? Why? Because survived, you can see 0th percentile is 0. That means the lowest value is 0. First percentile is 0. Fifth percentile is 0. And let's do one more. Why to skip this? Our good old friend, which is the median. What happened? Refuses to come? No, there you go. So median. So you can see, I mean, this doesn't look like I mean, it doesn't even make sense. Why would survive as an outlier, right? It's 0 and 1. So either you are surviving or not surviving. So there's no outlier utility here. Passenger class also first, second, and third. No outlier scope over here at all. Gender 0, 1, right? No scope for outliers. There is one scope for outlier over here in the age. In the age. But shall we fix the age? We shouldn't. I mean, if there was somebody like a senior citizen traveling on the ship, I should know that, right? I mean, that they are senior citizen, right? If there was a very young baby traveling on the ship, I should know whether there was a baby or not, right? So why should I artificially say, no, you're not 1 month, you're now 1 year, right? So why would you do that? There's very little utility. So just don't go blindly and say, I'm going to fix all the outlier under the sun, right? You have to be very aware of what those variables are and does that require an outlier treatment or not, right? So in this case, I'm going to leave it alone. Sibling, spouse, well within the range also, right? That's right. But this doesn't make sense. Fair. Fair doesn't make sense, right? Why fair doesn't make sense? So you can say 95th percentile was 112 pound. That means 95% of the people paid 112 pounds or lower fare. But these are super rich people or super lazy people who came in very late and say, I must be there on that ship to die in the ocean. And they paid a very high fare, right? And they paid like, through their nose to be there on that ship, right? And some very high fare, right? But that fare is not necessarily a good replica or good approximation of what is happening with the majority of the passenger, right? So that's where this is going to be fixed, right? How we're going to fix that is the next step. Shall we break now and then come back and fix it? Or you want to fix it and then breathe easy that you fix everything? Break? Okay. Let's break and then we'll come back and fix it, yeah?